So with the power rule, we have this funky notation going on. So as you can see from above, whatever is inside the brackets is your function. And this d over dx stands for the derivative of your function with respect to x. And then it tells you what it's equal to. So I'm going to make a little note here so you can understand that. This is, inside your brackets is always your original function. And then this is the rule. So you can see it's saying your original function is x to some power, n. So whenever you go to do your derivative, the pattern that these mathematicians noticed is that every single time you had that power number multiplied out front and the power was decreased by 1. So let me show you an example. You all know the equation f of x equals x. At least I hope you do. That's the linear function, the one that goes up 1 over 1 and goes through the origin, and it's a straight line. It's the one from which all other straight lines come from. So if we want to find the slope of this function just by looking at it, we would say up 1 over 1, oh, the slope is 1. Well, let's apply this rule and check ourselves and see if we were correct. So our hypothesis is that the slope equals 1. Now let's check it using calculus. So our n here is 1. So our n in our example, and I'm going to highlight that to show how it moves, the n is 1. So then we're going to end up doing n out front. So we're going to multiply the exponent to the front. Got to write my notation, f prime of x. We're going to multiply that to the front. So we're going to have 1x to the 1 minus 1. So that's how we use this rule. X to the 1 equals, or the derivative equals, 1 times x to the 1 minus 1. Let's simplify that a bit. 1 times x to the 0. And hopefully you remember from algebra that anything to the 0 power equals 1. So the derivative is 1. Derivative is slope. So that matches our hypothesis. This one, like I said, takes a little bit more work because the constant rule, anytime you have the derivative of the constant, is just 0. But here you have to do some math. Whatever your power is, you multiply it to the front and then decrease your power by 1. So let's start with f of x equals x to the third. So we write our notation, f prime of x equals, identify our power as 3, and then we're going to multiply it out front just like our rule says. See that here? So our derivative is 3 times x to the 3 minus 1. So f prime of x equals 3x squared. And that's the derivative. So if you want to find the slope at any point on the cubic function, you just take your x value and plug it into this derivative. Now they do get a little bit trickier. Say you have a cube root. You have to know how to change a cube root into an exponent. And we learned this in Algebra 2, that you can unwind the radical and the power underneath goes over the power outside. So first I'm just going to change the way this looks. I'm going to change it to g of x equals x to the 1/3. So now you can kind of see the visual that fits this rule. So according to our rule, g prime of x is going to equal 1/3 times x to the 1/3 minus 1. Now here's where you have to kind of be decent with fractions, because 1/3 minus 1 is negative 2/3. So our final answer is 1/3 times x to the negative 2/3. If you remember from algebra, we really don't care much for negative exponents, so there's a bit more we could do here, and what it will look like in the end is g prime of x equals 1 over 3 cube roots of x squared. So what I did was I moved that to the denominator and then I rewound it so that it would look like a radical rather than a fractional exponent. So there's that one. And then for our last one, we've got a y equals, so our notation here is going to be dy over dx. And, uh-oh, this x is in the denominator. That's not what our rule has. So can we even do this one? Well, yes, we can. But we have to manipulate it a bit first. We have to do something that Algebra 2 told us never to do. And that is change this to a negative exponent because we want the variable base in the numerator. So let me say that again. We're going to change this exponent to a negative exponent by moving the base to the numerator. So now it's going to become y equals x to the negative second. That allows us to use our rule. The way it looked before, we couldn't use it. And so now we're going to say the derivative equals negative 2 times x to the negative 2 minus 1. A lot of students get mixed up here. They think decrease by 1, and they change it to negative 1 right here for the power. But that's not true. Our dy over dx is going to be negative 2 times x to the negative third, and we move it back down to the denominator. So you might have to watch this video a couple times to kind of refresh your memory on these algebra rules. And if you need to, you can ask me more about it in class. We'll surely do some examples like this. But that's all you have for today. So be prepared to practice these tomorrow in class.